Here is an introduction to galaxy taxonomy to accompany chapter 26 of the textbook Astronomy from Open Stax. So what do I mean when I say galaxy? This is an example of a galaxy. So it's basically just a bunch of stars, roughly billions to trillions for the most part, but it could even just be tens of millions to tens of trillions. A bunch of these stars, usually some gas, some dust, and dark matter bound together by gravity, and that's what a galaxy is. So they don't all have this shape, as we'll go over. There's lots of different. So when you look out into the universe, this is a part of the Hubble Ultra Deep Field. Most of the things that you see here are galaxies, and there's just many different shapes. And so, of course, you can categorize these. You see several look sort of like have a ball shape, and many have sort of more like a spiral, sort of pinwheel type shape. And then there's sort of everything, in between. So the common way to classify galaxies, this galaxy taxonomy, is the Hubble classification scheme. So all that we've done here is just grouped our galaxies by their shapes. And so these ones over here, these sort of spheroids, these are known as elliptical galaxies. So they're really more ellipsoids, but whatever we call them, ellipticals. So you have anything from spherical to something that looks sort of like, American football. Then, of course, over here we have the spirals. So your spiral can have sort of a tighter winding or a looser winding, and that kind of takes you from A to C. And you can have a barred spiral, where instead of sort of a spherical bulge at the center, instead there's a more elongated, maybe peanut-shaped thing. And then in between these two, you have the lenticular galaxies. So this is something that kind of looks like a hybrid of the two. So you basically can imagine something that's kind of disc-like with a relatively prominent spheroid at the center. So this is our classification scheme that covers a lot of galaxies. Of course, there's a lot of weird stuff out there that does not fit into this classification scheme. So for instance, you have this object that appears to have been disrupted gravitationally by a close encounter with another object, probably another galaxy, and so has been stretched out into this sort of amorphous shape that's really hard to describe. You have this really awesome object here that's a ring-type galaxy, and in this case, there are some clues as to what probably happened here. You probably had an elliptical galaxy merge with a spiral galaxy, and your remnants of your spiral galaxy form this ring around this core that is the elliptical galaxy. So this doesn't really fit into the classification scheme. Neither does this. Neither does this one. And there's a lot of objects like this. So roughly, what is the breakdown? For the visible universe, that can get complicated. It depends on how powerful your telescope is. But let's just look at the nearby galaxies. So if we focus on our Virgo supercluster, these galaxies are pretty bright. They're nearby and we can see them. Then you can do a kind of accounting or a census of your different galaxy types, and you see that most galaxies, a simple majority, are spirals. Of these, about 2/3 are barred spirals. So in general, there's a plurality of barred spirals in the universe. Then you have a lot of lenticular galaxies. So remember, these are ones that are kind of a hybrid between the spiral and the elliptical. And then finally, elliptical comes in third. So you have a lot of those out there. And then there's a handful of these irregular or peculiar type galaxies. So ones that don't really fit into this Hubble classification scheme. So let's just briefly talk about the structure and the differences between these objects. I'm just going to focus on the spiral galaxies and the ellipticals because, as we said, the lenticular are just something in between, and the irregular, there's not really a good scheme because there's all kinds of weird shapes out there. So let's just focus on the two main types. So spiral galaxies, as we covered in our introduction to the Milky Way structure, you have a bulge at the center. There is a disk. The disk is characterized by some spiral arms that emerge from the bulge or the bar at the center. And these can have, various tightnesses in the winding. And then there's also associated with the spiral galaxies a spherical halo of stars. And you tend to have, young and some old stars in the disk, and then older stars in the halo. So typically you're somewhere between 1 billion and 1 trillion stars, young and old. These are typically about 20,000 to 100,000 light years wide. If you remember the introduction to Milky Way structure, then you know that the Milky Way is actually pretty big. It's on the high end of the stats here. They rotate in a way that you sort of think they would, so the spiral arms trail, so this galaxy here spins in that direction. And that just means, that's the stars are orbiting the center in that direction, so the whole thing is basically rotating. And these galaxies have a lot of gas and dust. And the gas is what enables star formation. You need fuel to make stars. And so it makes sense that you have young stars in these objects. And when we say dust, we just mean, you can kind of think of it as really large molecules. So the gas is kind of condensed into these larger type objects that do a lot of light absorption. And about 2/3 of these are barred, and we don't know, but the suggestion is that this must be some kind of long-lived structure, because if a galaxy is let's say a galaxy is changing shape over time, then if you see a lot of them, that means they must be spending a long amount of their lifetime in that shape. So there's some thought that perhaps spirals evolve into the barred spiral structure, though that is not for certain. And then ultimately, these are also thought to evolve into a lenticular shape. So the idea is that once star formation ceases, you no longer have star formation preserving the arms. So we talked about this in our Milky Way lectures, that star formation is thought to preserve the structure. And so if star formation goes away, then you'll kind of wind the arms up and get something that's more like a lenticular. So your bulge basically stays there looking like an ellipsoid, and you have a disk remnant there. That's the thinking anyways. And then finishing up our galaxy types, the other main type is these are elliptical galaxies, and so they make an ellipsoid shape. So for instance, you can think of something that looks kind of like an American football. You could also think of, so this is a prolate spheroid. You could think of an oblate spheroid, and that's more like volleyball if you deflated it a little bit and stepped on the top. That's also a shape that you could have. And then spheres are included in this as well, so spheroid type objects. You have a really wide range of properties compared to spiral galaxies. So you can have anywhere from, around 1 million or so, or a little less than that, stars, all the way to, tens of trillions of stars. They're mostly old, and the sizes vary widely, so just a few thousand light years wide, so not much wider than the thickness of the Milky Way's disk, all the way out to these giant things that are 7 times the size of the Milky Way. So just a very wide variety that you have here. The stars, orbit in many different directions. So unlike a spiral galaxy where your stars will be all orbiting in a common direction, here you might have some orbiting kind of into the page, some out of the page, some around, kind of like a belt. So they're just orbiting in lots of different directions, and there's basically not much bulk rotation going on. There's also not much gas and dust. So the gas is kind of condensed into stuff or left the galaxy, been blown out by star formation, and so there's just not much gas or dust left there, and that's consistent with there being, mostly older stars. And some of these, in particular the larger ones, are thought to be the result of mergers that involve spiral galaxies. So this nice spiral structure was basically busted apart by two really massive objects merging with each other. And that is it for this introduction to galaxy taxonomy for Astronomy 1000.